Hello everyone, I am engineer Antonio Limena from DuSE, and in this video tutorial I'm gonna show you the basic use of ProSap, especially the use of main controls of what concern the modulation, the load application, the check of the analysis results, and the design. First of all, we are going to change the software language from Italian to English, so we have to go to Preferenze, Interfaccia in Lingua, and we're going to check English. Okay, now every control is in English language. As every other software, on the top left corner we have our file button that allows us to save, to create a new project, or to open all the projects. Also here we have a list of the latest projects that have been opened recently. This tab here, input data, shows the context in which we are actually working. But to explain you better, I'm gonna now open another file. So I'm gonna open another PSP file. This is a file with a structure similar to what we are going to basically to create at the end of this tutorial. And what I wanted to show you is that when the file is done at the end of the project, here in the top section of the window we are gonna have 4 different tabs that each one represents one of the 4 main steps in which the project is divided into ProSap. So the first one is the input data that allows us to create our model using basic controls like generate, basically everything to edit, like move, copy, rotate, mirror, etc, etc. We can switch graphic from wireframe to solid view, and so many other things that we're gonna check lately. The second context is load assignment, in which you can see that all the ribbon bar here changes when we switch from context to context. In the load assignment we can, as it says, assign loads to our structure. In the view result we can check the results of the analysis. And in the assign data design we can design our structure. So before our analysis we can check if the structure is verified or no, based on the normativa that we're using. So this is a very important thing about ProSap. Is very particular, and you have to keep that in mind, because due to the context in which we are working, some commands like edit, that is always present in each ribbon bar of each context, but it works differently if we are in a context or in another. For example, in the input data context, if we go edit an element, we are gonna have so the properties window is gonna show up, and we can check all the properties of the selected element. Instead, if we are in the load assignment and we go edit on an element, what we have is a window that show us all the loads that are applied to that selected element. So you have to keep in mind the difference between contexts, and you have to realize the importance of one instead of another. Okay, this is the first thing that I wanted to say you, because I repeat, this is very important in ProSap. And now I think I can close this project, go to the empty one. So we go File, New, basically. And we're gonna start model something. Okay, so first of all I'm gonna start generating some basic finish elements like nodes D2, D2 and D3. Nodes D2 and D3 are the main finished elements that are available in ProSap, where of course nodes is just an adimensional element in which we can here give of course coordinates, and then click OK to generate it. When we use one of these commands, we have to let's say give the correct input in this window, and then only when we press OK, the element is gonna be created, and it is going to be highlighted in red. One important thing is that I'm now writing in centimeters. To check the unit measure, you just have to watch under there, in which is stated that length units are in centimeters and force units are in decanewton. Also, now that we are talking about the bottom bar, we have of course coordinates. So if I go on a node, on an element, this shows me the coordinates of what the indicator is doing. And here down there we have the number of elements in our model. So maybe it's too soon to talk to you about this, but let's go on. Okay, first of all, before starting generate elements, I want to talk about archives. So in ProSap we have under the voice structure data here on the top left, we have two very important archives that are sections and materials. That are properties that we are going to assign to our elements. First of all, materials, of course, is an archive, sorry, of materials that is already pre-compiled, is already filled with a lot of materials divided per type. So we have 5 different kind of materials in ProSap. The first is concrete, that has his list of properties. Then we have steel with another list of properties, and then masonry, wood, and user control maybe. So this is a what's the name? Generic material. Okay. Every material has its own kind of verification at the end of the project. And instead the generic material can't be designed because it doesn't follow any kind of rule. It's just something that we can use to help us on the design, on the modellation, but elements created with generic material are not going to be designed, sorry. Okay, so this is the material archive. Then we have the section archive. Here too we already have some kind of sections to fill our archive, but basically we can create our own. We have generic sections of each form. We have simple profiles for steel, and also coupled profiles from steel. So we can have a generic section in which of course we click on the shape we want. We can here have a name, and then we can give them parameters, so base in this case and height. Here we can select for the intended use, so the the kind of element in which we're going to assign that for concrete, for steel, or for timber. Instead, in simple profile, we can click on the profile and then select it from the database, basically, in which parameters are already inserted. We just need to select the dimension that we would like. Okay, for concrete sections, we also have section data. So this window shows us what are the main properties of the window that we selected and that we designed, basically. These are not editables, so they are just calculated from the software. What we can only modify is the cut area that we can decide to low down, so we can insert a lower number, also a higher number, of course, but it doesn't make many sense. And also, for some reasons, we can decide to low down or even to increment the percentage of stiffness. This is an axial stiffness, flexural stiffness, and torsional stiffness. So if we have an element and that in particular we don't want it to work for some reason in the actual way, we can reduce this value from 100 to 1, something like that. But maybe this is something just advanced, so we're gonna pass by. Other tabs show us shear reinforcements, in which we can specify what's the diameter of the stirrups and some other say parameters, always talking about the shear reinforcement, so basically stirrups. Instead, the longitudinal reinforcements is about, of course, longitudinal reinforcement, and in this window we can just say to the program how many reinforcement do we want to have. This is the minimum amount of reinforcements, longitudinal reinforcements, that the program is gonna use when we're going to design the elements. The program can also use more longitudinal reinforcements than what is inserted in this window, but never less. So this is it. Okay. This is all for the table of sections, and now that we know what's the section and materials, these are something else that maybe it's not of your interest right now. We are gonna start with the modulation. Maybe some other commands will come lately. First of all, I already show you how to use the command node. It's very simple. You just have to click node and select the coordinates. Instead, if you want to create a D2 element, so a linear element, we have different options. We can use the basic option, in which we have to click the first and then the second node that are gonna linked by the D2 element. When we click on nodes, we're gonna see this fine red line. That doesn't mean that the element has already been created. In fact, if I click X or exit, and then I zoom out and in to refresh the view, the element is not gonna show, because the element hasn't been created for real. To really create it, we have to click and then press OK, or of course enter. Now that the element is thicker and red, we can press ESC to deselect it, and if we zoom in and zoom out, we can see that the element is still there. Another important thing is that, for example, if I create a node here, now I'm gonna delete this. To select elements, there is the command near. When we click near and it is selected, so there is this blue box around the command that is saying us that the command is active. we can click on the element, it becomes red, so an element is selected when it becomes red, and then we can cancel it with the cancel button of your keyboard. So what I wanted to show you is that if we use this command and we want to create more linear elements in a row, if we go click 1, click 2, and then click 2 and click 3, and I press enter, only the second element is going to be created. So if you want to create multiple elements with one command, we have to click OK or to press enter on the keyboard for each element. So now I'm gonna delete this, and I'll show you the real, the appropriate passage. So click 1, click 2, enter. The element is thick and red. Click 1, click 2, enter again. Now if I close and I go ESC to the select, we have both elements. Okay, about the selection, of course we can click select all to select everything, and deselect all, that is the same of ESC, to deselect everything. Okay, of course with the command box we can click and click to select only what's in the box. Like AutoCAD, if you have already used it, if you select from left to right, your ProSap is going to select only everything that is entirely inside my box. If instead, if we select from right to left, ProSap is gonna select everything that is in minimum part inside the box. Like this element was not totally inside the box, but it still is going to be selected. Instead, if we go from left to the right, it's not. Okay. Now, this is the first way, the main way to create double G2 elements. I want now to delete everyone. Okay, cancel. Okay, instead, okay, I'm gonna show you another command. Okay, of course, on the top left corner we have undo and redo. So if we misclick, if we miss an action, we can just go back and do the action with this command. And I wanted to show you also the command property that allows us to select elements based on their properties. So now I wanted to cancel just the two elements but not nodes. With this command property I can select elevation beams. Of course, now then we can filter with material, section, number, thickness, so many other parameters that in this moment are not significant, and then press OK. And we see that the program is selecting only the two elements, not nodes. If I click cancel, these elements are cancelled. Now I'm gonna click also this node because I didn't want it. Another way to create a D2 element is this command, D2 element from node, in which basically we can click on a node. When we click it, this coordinate, X node, Y node, and Z node will change. If I click one on the origin, they are 0, 0, 0. If I click this one, they are 100, 0, 0, 0. And then we can give let's say the offset, so the distance of the length of our D2 element. If I want to create a column, I can give delta zeta of like 300. If I click OK, we see that a D2 element of 300 centimeters of length is created. To check it, we can press near, go without clicking, go near this node. You see that when you go near an element that is diciamo, is going to be selected, it's highlighted in blue, not in red. So if it's highlighted in blue, it's going to be selected. If it's highlighted in red, it is actually selected. What I wanted to show you is that if I place my cursor over there, on the bottom right corner you can see the exactly coordinates of this element. So 100 on x, 0 on y, and 300 on z. Okay, this is very basic things, like first things you need to know. Also, let me think, here we have these are advanced commands. Basically you're just going to use the do element and the do element from node. Same for the try element. So we can create a d3 single element just by clicking on nodes, like at least 3. If we click on 1, 2, 3, now if we go OK, then we have our d3 element. When you try to select the d3 element, the blue highlight is the inner form, the inner shape of our element. If we click, it becomes highlighted in red. This is of course the basic command to create the try elements, but it's also the less used. Basically what we are going to use more is mesh, the try mesh by 2 points, in which we give simply 2 nodes on the opposites of our element. We give as input the number of parts in which we want to subdivide it, like number of parts on E4, number of parts S, so in IG, let's say 10, just to check the difference. If we go OK, the software automatically generates this mesh, in which that is subdivided in 4 elements for E and 10 elements for S. Okay, another kind of commands to create walls like this is, now I'm gonna undo. I'm also gonna cancel this. We also have the 3 mesh by 4 points, so it's basically the same, but we have to select 4 points instead of 2. We have polygon d3 mesh that is very useful to create a mesh that let's say that touch different points that maybe to create a mesh that it's not regular. Let's have an example. I'm going, oh no, okay, okay, I'm gonna cancel this because it's it have a zeta quote that we didn't want. I'm gonna create some random nodes, so like 100 on y, 100 200, no, sorry, I said 0 zeta. So this is 0, this is 200, and let's say 150, 200. Okay, so now we have some nodes that doesn't create a quadrangular mesh. And so to create a mesh that touch all these nodes, we use a polygonal d3 mesh. So we can click on each one, then press enter, and the software is gonna create the mesh. So okay, basically these were the different ways to create the main finished elements that ProSap gives you, like nodes, d2 and d3. Okay, let's these were generate commands. Basically we already saw what is about selection. Another important command may be this all on. Basically when we select an element, we can right click everything everywhere on the display, so you don't really have to double click to right click on the element. If we right click everywhere on the display, we can have display, hide or isolate. If we click hide the selected element or elements are going to be hidden, and with all on everything is gonna show up again. If I select instead, like this portion, if I go right click display isolate, the software is going to isolate only selected elements and hide the rest. It is very important to know that when you select an element like a D3 element or RD2 element and you go for isolate, the software isolates only the D3 element, so there are no nodes in this selection. You see, I cannot click on the node, there are no nodes in this selection. Now I go all on, you see there are the nodes. To isolate also nodes, you have to click the elements and then right click display isolate topology. If you do this, the software is going to isolate not only selected elements but also every element that is topologically connected to it. What does it mean? That a D3 element basically is composed by a plate, so a shell, the proper D3 element, but it's also composed, topologically talking, of also nodes. So when we click an element and we go isolate, it's gonna show only the shell. If we go isolate topology, if it isolates everything that is connected to it. Another example, of course, if I click instead just this node and I go display isolate topology, it's gonna show me every element that is topologically connected to this node. So the 4 D3 elements and also the nodes that appartengono, that sorry, I'm missing the term, but I think you understand. So we can go on. Okay, now this we seen basic selection, generate view. Basically allows me to graphic is I can switch from wireframe to solid view. In solid view, of course, I can see the solid view of the model like wireframe, and in hidden lines it doesn't change that much, but okay, I can use these commands. Okay, maybe this is not very significant because our plate have 1 millimeter or centimeter of thickness. Let's do this. Okay, let's go wireframe. If we go edit on an element, this is the property window in which we can change some properties like element type. Shell or membrane are the two options for the 3 elements. Basically, shell is a full rigid element. Membrane is an element that has zero stiffness outer plane. So it has a stiffness only in his definition plane, but no stiffness for orthogonal actions. Basically, we're going to use shell, and here we can modify the stiffness. We can put 10 centimeter. When we modify something, we have to click on another property to make it real. We are gonna we see that this property is now highlighted in black. It's now bold, let's say this. And this happens because this command instant apply is usually selected. If I click it, you see that the properties now is black and not red, and if I modify something, let's say that I come back to 1, if I click somewhere else, this is still 10. Like, I can close this. Let's go solid view. You see now this element is higher than the others. So if I go ahead, and now it's still 10. I should add click apply changes to apply my change, but basically this is just for your information. You normally have to keep this command always on. Now, one important thing is that if I want to assign this property to each other element of my model, there is a procedure called assign reference. Basically, it works with this command, that is set properties and apply. So when we use this, we are saying to prop to save the properties of the selected element, not the selected, sorry, the editing element. It's very important to distinguish between select and edit. They are two different things. If we select something, it becomes red. If we edit something, it becomes like this. It's blinking. I'm gonna deselect. So when we select something, we cannot change its properties. When we edit it, yes, we can. So, of course, if I need to change the thickness of my plate, I cannot go edit in each one and modify. So, the proper way to do that is to go on just one element, change the property, so the thickness from 1 to 10, then we click on set properties and apply. You can click it a couple of times to be sure the command has been taken. And clicking this command, basically prop saves the information about this kind of element. So now if I select other elements like this, I can go right click and then assign reference. Of course, I can assign every single properties. In this case, I can just say assign thickness. With assign reference, you assign to these elements every properties. So assign reference, I go ask, and then you see that these elements are the same color of this one. Because in prop the elements are colored based on their thickness or on their section, if you're talking about the two. If we go solid view, we see that this is thicker than this. So the command has worked. Another thing we can do is to assign, like right now I just clicked on them one by one. Of course, to be faster, we can use property. Instead of elevation beams, now I select slabs. I give him OK. Everything is selected. Right click, assign reference. If I go ask the select, I now see that everything is orange. If I go solid view, everything has 10 cm of thickness. So this is very important that because it allows you to work really much faster instead of selecting things one by one, and it's very important to understand this how this command works. It's not that simple, I understand, because it's something that maybe it's not used in other programs or other software that you may have used, but once you learn it, it's gonna be simple. Okay, so we have seen basic commands for what concern generate and selection, and well, view. Of course, you can go view and select your predefined view, like zeta plus is from the top, zeta z meno is from the bottom, and the same is x plus x slash. Okay, maybe with just a plate that's not doesn't change that much, and these are isometric views. Instead of this, of course, you can click on the window to rotate your model. Let's go back to wireframe. And okay, with filter you can select which kind of elements can be selected or not. Okay, to this example I'm gonna first create a D2 element, so let's go D2 from node. I'm gonna select this node, thread chain 300 is already correct. Okay, let's say now that with filter I click exclude nodes. If I go near with this command, I can select only D3, D3 and D2, but I cannot select nodes. On the other side, if I click only nodes, of course, I can click only nodes. I can select only nodes, but I cannot select anything else. This may be useful in some situation. It's good to know, basically. Okay, with the set instead you can set references without edit an element. So lately I used the edit on an element to change properties and then set reference. Instead of this, you can just go set the reference. It shows you the actual reference, and then you can change from there. I go 100. You always have to click this. Okay, maybe 100 is too much, but you understood now. If I go 20, I click this. I show you this again because this is very important. Near, right click, assign reference, new color, graphic solid view, different thickness. Okay, I'm gonna undo this. So this is the command this is set command. With this command you can select by plane. Like this is XY plane. If you click it, you just have to give him like 1 point, basically just 1 point, and the program is gonna select everything on the plane of the selected point. So I selected this point, I go OK, it selects me, not only select and what's the term, and isolate everything that is on that plane. Now to come back to everything, all on, and shows me everything. What are we missing there? We just okay, we can talk about edit commands. Well, they're very simple. I can with near I can click an element, and with move you can just move it. So there are some different ways to do that. You can just, let's say that I want to move it from there to there. First of all, I should not select this node, because if I move this node, the topological definition of the D3 element is gonna give me an error. So I'm just selecting these two elements, move. If I want to move it from a node to another, I can just click on a node and click on the other node. And you see that when I click nodes on this window, the program automatically fill these properties, and you can see what are differences, I mean the distance between the two nodes. If I go OK, it is moved. Let's say that I don't do that. I can go move just by editing. I mean, in this case I know that if this is 150, 200, this is 200 and 100, so it means that the difference is 50 on X, so I can go 0, 50, and 100 negative on Y, so I can go 0 and less 100. Okay, we see that the result is the same. So basically when we click we help PROSAP to fill these fields, but we can also edit them with the specific instance that we want to move the selected object. Okay, go back. When we use instead this copy and move, is basically the same, so it works in the same way. We can click nodes or we can edit fields by our own. If we go OK, the element is copied and moved. Very simple. Okay, basically this is main commands. Then you can rotate, mirror, scale. These are quite simple commands. One that can be useful is divide. That basically divide selected elements in equal parts. So if I go divide, you see that a node has been created there, and if I go here, these are different elements separated from this. If I go again on divide, it's going to divide the single elements in two parts. So divide basically divide each selected element in two equal parts. Something different instead is intersect, because this divide the element just by the node. So one important thing is that with this command split up view, you see that if I activate the program the view is changing, and now elements are not strictly connected to the nodes, but they are a minimum far from nodes. This allows me to understand if an element is correctly connected to a node or no. Why I'm saying this? Because let's say that I want to build a D2 element here. So I'm gonna cancel this. Okay, I'm gonna create a D2 element from here to here. In this case, we have some nodes that are inside, that should be on our element, that should divide my element. But normally in prap, when we generate an element, internal nodes are not included. So if I go OK and then I split up view, you see that this element seems to be connected only to this and to this node, because here there is no white space like this. Instead, if I select this element and nodes inside, okay, I don't even need to click nodes. If I click an element that have some nodes inside and I go with the intersect, you see that one by one, so you have to click it multiple times, the software divide this element using the nodes. And another important thing about modulation is what concern basically hinges and boundaries. So to connect your structure, your model with the ground, basically with the external environment, you need to use so boundaries that you can apply on nodes. So you go edit and then you click on nodes. Basically, here nodes properties are basically about position, about the possibility of insert a foundation that we're gonna see, and here you can simply click these boxes that stands for translation X, translation Y, translation Z, rotation around the X-axis, rotation about Y-axis, and rotation about Z-axis. And when you click for each one of these, you're going to fix these degrees of freedom. So for example, if I click only this, it means that this node is able to move in every direction and to rotate around each axis except for the X direction. If I want to fix something on the ground entirely, we should pin them all. So here we have a fixed node that is not allowed to move in any direction and to rotate around any axis. You can also check the color of these little triangles that appears around the node when you click them. So when I have just translation boundary, it's blue. If we transform them on rotation boundary, they are green, and when we have them both, it becomes red. Okay, and of course you need to have some boundaries to let the program go for the analysis. Otherwise, there are gonna be no results, and the software isn't able to make this analysis. And another way to place boundaries with the external ground is with the foundation property. Oh yes, okay, one more thing. These boxes are for a full stiffness boundary, so a rigid boundary, but you can also have elastic boundary. When we don't click that, of course, we can select the stiffness of the boundary on for each degrees of freedom. Of course, if I fix translation on X, I cannot input a value for the elastic boundary on translation on X because it's already fixed, so is one or the other. As I was saying, another thing, well, with this button apply, you can instantly fix everything. And another way, as I was saying, to consider your structure fixed to the ground is to use the foundation property. So if we go edit on a D3 element, in this case, we can click this. We can pin the foundation bottom face. That means that this element is now a foundation element. So it's considered connected to the ground, and we have these two parameters, k soil vert and k soil horizontal. That is basically the factor k of Winkler that represent the stiffness of the springs bed that connects the element with the ground. Of course, you can put the value that you would like. Basically, one is a good value to start analysis, and then based on the results, you can change it after the analysis to repeat them. And when you have an element become a foundation, if you close it, okay, you should see it a little thicker. Let's say you can use that, of course, on D3 and on D2, not on nodes. On nodes you have to use external boundaries. So here is, if I use foundation, okay, you see that the element is thicker. So when an element is defined as a foundation for the DUE, they appear thicker, so you can immediately see which they are. Okay, so let's take out this. Another important thing about boundaries is are internal boundaries, also known as hinges, that you can apply on D2 elements, and they are here under the voice release codes. They are node release. If I click N, for example, it is a release of for the axial force. V2 and V3 are for the shear force. M1, 2, and 3 are for flexion around this axis. So this allows me to introduce a new concept. What does 2 and 3 or 1 stands for? Okay, they stands for the local axis of the element. We can see them by going preferences, elements option. Here we have a table of which we can basically see or not in our model. Here we have the DUE element local axis. If we click it, we can notice that on the DUE elements it appears they appear this little local axis in which each axis have a different color. They follow the rule of RGB, so red, green, and blue. So R is red number 1, G green number 2, and blue number 3. It's the z-axis, or maybe just number 3. This means that when When I pin N, it's like a V1 basically, so it release forces in one direction, in direction 1, so the actual forces on the element. V2 are shear forces on direction 2, RGB, so G is number 2 green, so in direction of the green axis. Same for free. Same are for fractional, which stands for around axis 1, around axis 2, and around axis 3. So M1 is the torsional moments, and M2 are fractional. Of course, we have two nodes, so node E and node J. We can see that I click here. When I click, when I release some degrees of freedom on the element, they appear these like little spheres. And so you can see that in this way I applied only a release on node J, that it's the upper one because this little sphere appears on top. If I also click this, it appears also one on the bottom. Basically this is useful, especially when we are designing some steel structures, and generally when we have to model truss elements, because what we're going to do is to pin everything, okay, except for N. That means that the element is working only on actual force, and of course by consequence it only has actual stiffness. Another way to do that is simply to change the element type from beam to truss. When we change from beam to truss, you see that we have no more end release options, because it's automatically released on the end for each force, for each kind of action, except for the axial actions. Okay, so I think this is all for what concerns fixes and boundaries. Of course, what I suggest you is just to try the software, spend your first time on the software on trying commands, trying controls, create things, try to move them, try to modify, and this is the best way to learn how to use it. And of course, then if you have any question, you can make them to me, and I'm gonna answer you. Of course, I'm gonna constantly help you about the use of the software. What I was gonna say, okay, last important comments about modulation and edit what I modeled, I think is stretch box that allows me to move a node and all elements connected to this. So I need to select the node that I want to connect, and if let's say that I want to move it on X, I'm gonna go 0, 50. I want to move only on X, so here I place 0, 0, so the difference between initial and final is 0, 0, and 50. If I go OK, you see that the selected node translated of 50, and all connected elements moves to maintain, let's say, the correct topology of the structure. For example, if I use just move with the same parameters and I go OK, only the node is going to be moved, but not the related elements. Okay, so now I use the stretch box, because stretch box basically moves everything that I select of the exact amount I insert here, and then all the rest, everything else that is connected to this element is gonna move by consequence. Instead, when I use stretch node, I don't even need to select the node. I just do the first click on a node, and the second one where I want to place it. But this works only with single nodes, not with selections. Instead, like with this, we can select also a box of elements, and if we go with a translation of all the box is translated and the related elements are consequentially stretched. Okay, Control Z. Okay, so I think it's time to try to move on to the next tab, so to the next context. But before this, one last thing about generation, so about the input data context. A very useful command that we have here is generate, that helps us to generate maybe big parts of the structure, like trusses. Just this is of course for steel structures. We have frames, 2D frames or 3D frames with slabs or not, with the foundation fixed each kind. We have slabs of also here different kinds, shell, and well other else that I let you explore by yourself. Let's focus on slabs because we are gonna make one of these. First of all, we cancel everything that we already modeled. Well, of course, this is nothing significant. I just created elements just to show you. So all on, sorry, select all to select everything and cancel. So let's try to use the generate slab control. We want to obtain a circular slab full, so we go OK, and now we have to select parameters. So center, the center of the plate, we can click a node, but in this case we have no one, so we just can keep the origin of our global local system, sorry, a global coordinate system. Radius we can insert I think 500 centimeters, 5 meters is okay, and the circumference part, let's have some tries. Okay, let's see what happens if we change these parameters. So if we go 8, our slab is going to divide it into 8 radial parts, and the dimension of these elements are proportional to this radial division. So to have a 5 radius circle divided in 8, the external, let's say the external border of these elements should be this length, and so also the other dimension of the 3 elements is let's say proportional to this one. If instead we generate a slab in which the division is accelerated, so 16, let's move it like this on X. If we go OK, we can see that now the radial division is 16 instead of 8, and of course also the let's say linear division along the radius is higher, so we have 4, 5, 6 instead of 1, 2, 3, because the dimension of this side of the D3 element is exactly half of this, and so the shorter side of the 3 element is okay. Of course we can go on with this. If instead of 16 we go 32, let's go on with this. The more of course the more we subdivide the radius, the more precise our results is gonna be. In this case let's check within here. We have here an an x coordinate of 1946. So this means that one side of the three element is 46 centimeter. That is generally a good dimension for a D3 mesh. So I'll keep this. We can cancel the rest. We go with box. We can cancel like this. So I never said this before, but if you select an element by error, you can control click it to the select. So we go near, I go control and I click the element. Now it remains red, but if I zoom in and zoom out to refresh the view, it becomes black. And now we can cancel everything. Now I'm gonna move the last slab on the center of our global coordinate system. So select everything, move from central node, well, actually to 0. We don't have a node is 0, but I can type the coordinate here. We go OK, and this is it. So now we have our slab. One important thing to do before move to the next context, as I said before, is to set the foundation property and all other properties. So we go edit. Now I'm going faster because I already said these things before. It's just a recap. So edit, click on the element, we select the thickness, let's say 50. The material, the design setting, we're gonna check this later, and stop the check on foundation, and we're fine. Now we just need to set properties and apply. We can go, now we have two different ways to select everything except nodes to assign properties. We can go properties, slabs, okay. Either way, we can go filter only D3 and go select all. Right click, assign reference, and now everything is yellow. Now that we have our slab, we would like to model a slab, basically a foundation slab with variable thickness, with tapered section, basically. So to do that, actually prap doesn't have a real command to make that possible, but what we can do is to divide and to assign each circle of my slab mesh and assign to it a different thickness to proceed gradually and go from the minor thickness to the major thickness, from the border to the inner elements. Okay, this is we can do like this. Let's say that we want to go from 50 centimeters to 1 meter. We divided it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's perfect. We can go from 10 to 10. No, sorry, from 5 to 5. If we go from 50 to 100, we have 50 centimeters to scale. Divided into 10 steps, we can go 5 each time. So now what we have to do is go zeta top view, just to view it easily. Now we need a bit patience, because it's hard to select circularly. No, in reality we have a command, it's box circle. We can select circles, so we can go like this. Let's say that we want to select only this, because the external one is 50 centimeter, is already right. We want a second one, so what we can do, go right click, display isolate, so we are hiding the external one. Now I can use again box circle. I select the inner ones, hide. Now I have only this one, so I can edit an element. Instead of 50, I'll go 55. Set reference, filter only the three, select all, right click, assign reference. Next. And now you can see all this circle changed its color. Now we can repeat this process each time it's needed. So all on, box 3D box, we can go from, no sorry, box circle, right click, display isolate, box circle. Okay, without note is quite hard. To keep things easier, first I think I'm gonna change this to 100, and then assign reference. Okay, this just to change the color. Okay, this is much easier now to do. So box circle, as before, we are gonna select everything except the external circle, display hide, edit. We were 55, so now we are 60. Assign, select all, right click, assign reference, all on. Circle, this one, display isolate, box circle, no, too much, everything except the external one, display hide, edit, we were 65, so 70, select all, assign reference, all on. Let's check, I go 60, okay, this should be 75. Let's go undo. Basically we can have this 65, set, assign reference, all on. And now in the meanwhile we change thickness from circle to circle, the color are changing, so we can also easily recognize where we arrived. Box circle, all of these, I missed one. Display isolate, sorry, I keep forgetting that I should don't select the external one. It's becoming harder to select just what I want. Display hide, we were 75, so now we are 70. Select all, assign reference, all on, and you're gonna continue like this. We have 70, so the next is 75, display isolate, display hide. Now we're gonna edit an element, 75, set reference, select all, assign reference, all on, circle, display isolate. It's no problem if I took two more elements, so circle, let's say like this, display hide. Of course I'm gonna keep this out, so display hide. We went 75, so we have to go 80. Set reference, select all, assign reference, all on, display isolate. Well, okay, we're gonna complete the selection just using near. Now it's simpler. Display hide, we were 80, now we have to go 85. Set, select all, assign reference, all on. Okay, now I missed something, I didn't reach 100, but I think it's okay like this. Let's say that we have from 50 to 90. Okay, the important thing is that you understood how to do that, how to create variable thickness in a plate. Now in fact, if we move a bit our visual and we go graphic solid view, we can see that we have a what we gained what we wanted. So we have a variable thickness slab, but as it is right now, maybe let's try the hidden lines, if it's something better. Not that much, I don't know why, but the vertical side of the slab it's not show up. It's not a problem. Now we have that this slab is has a variable thickness on top but also on bottom. We want to have this only on top. So now what can we do? We should use a property of the slabs. So edit, we select a slab. That is alignment. With alignment, you say to the program how is the medium plane of our D3 element aligned with the rest of the body. With centered, of course, it is on the center. That is the situation that is gonna use like the most of the times. But in some cases like this, we can use inner or outer alignment. In inner, I think it's the bottom alignment. So if I select this, set reference, now I can select everything and assign. I don't have to do assign reference, otherwise I'm gonna assign also this thickness of 55 to everything. I just want to assign the alignment, so instead of assign reference I'm go assign alignment. Okay, now I can click on another element to check if yes, it worked. And if we go hidden lines, now we see that our slab has a variable thickness just on top. On bottom it is everything at the same level. And so yes, basically now we are fine with our modulation, with our model. We have what we wanted to start from for going with analysis. And yes, now we can go on. When we want to pass from a context to another, we have to make ProSap do some checks that allows us to pass from a context to another and being sure that we didn't forget anything. For example, okay, let's see how it is done. With context, we should go check structures data. The software gives us a status check report. If no errors are given, it ended with process is complete. No warnings are given, so we can close. And now we see that we have a new tab available, the one for the context load assignment. Now let's say that during our modulation we moved a node far away from their D3 elements, like this. Okay, it's just an example. So now this node don't even more belong to these two elements. If we do the check, the software is gonna give us a warning, so it's gonna aware us that there are 3 nodes detected and ask us for the program to delete them. So yes, we say yes, it automatically deletes it. And now there's still a node missing there. If we go another check, another warning is given saying that there are probable errors in topological definition, and the software will automatically provide the correction. Repeat the check. We go OK. The software automatically creates the missing node, and then we can go again with the check, and now we have no warning, we can go on. So let's move to the load assignment context. Here the first thing to do is to go on load data and create load cases. We can use load cases. Let's say no. Okay, sorry. These are our load cases. So during the preparation of on the load assignment context, we have to create our load cases that are then further used to create combinations. And in fact they are of these kinds. So there are permanent actions, variable actions, and seismic actions of different kinds. We should create one for a kind, and using the command so load data load cases help. Here we have a window in which we can select which kind of load cases create, and in case also which cases to delete. So usually we select the first one, typical actions and structures, so permanent, variable, and seismic. It asks us if we want to replace, okay, because I already created them before, yes. We want to use seismic dynamic analysis, usually we say yes, otherwise only static seismic analysis cases are created, so we say yes. And then we can close this. This warning is not proper. I mean, seismic hazard or property side uses step 1, because after okay, we just ignore this warning right now. When we create load cases, now if you go check, we have a self weight and dynamic for each kind. Okay, now we should go on load data seismic load cases. Here we have a window divided into 5 steps, in which we can select and define the properties of our seismic load cases. So on step 1 we have the importance class of our structure. On the hazard and zonation we can go on seismic hazard and select which location our structure is placed. Right now this is only for Italy. I check Ferrara, and okay, you see when I select a locality, everything else is automatically filled. Here I can set the security level, or also set as the percentage of seismic action that is gonna go on our structure. Usually, so on default is 100% of the action. Of course, if we are talking about existing structures, we can low down it, but now we're gonna keep 100. We go OK, and then we can next on the next step. Step 2, we have to choose the foundation soil category and the topographic category. Next, on step 3, we can use the fattore di struttura, I don't know how to say in English that, and the ductility class of our structure. So we can go non-dissipative, medium dissipative, and highly dissipative structure. And here we can select the regularity of our structure in plane or on elevation. Of course, all of these properties are based on the Italian normative, so you should adapt it to the normative that you're going to use to design the structure. On the next step 4, we can insert what is the structure base level, so basically which is the ground level on our model. Usually it's 0, but in some other cases we can move move it. But right now it's like that, and with this button we can automatically calculate fundamental periods of our structure. To do that, the software needs to have let's say it needs some elevation structures, so some elements that are above the structural base level, because everything that is modeled above this level is gonna give structural mass. Otherwise there are no structural mass in our model, like in this case. We go next, and here we have another window on step 5, in which there are combinations factor, so for each load case how many mass it should provide during the analysis, or during the seismic analysis. Once everything is done, we can go and end. Now prap says to us that the mass appears null, because as I already said, there's no elements above quote 0, so anything is modeled above ground level. Okay. So just to make an example, let's go on input data and create a D2 element. So I'm gonna have a D2 from node. I select this node, I create an element height, let's say 10 meters. You have okay, so this is wrong. So undo, let's do it again, maybe this time with a 0 here. Okay, now we have our element. Let's say it's a column that it's posed on our base slab. Let's give it a proper section, maybe something like sections. We can have a circular section. Let's call it column, and let's give it a radius of a meter. Okay, apply. This element by default is created with the section number 1, so it's already assigned. If we go on solid view, it's already applied, and then we can once again go on check structures data. Everything is fine. So now we can go back on load assignment, do the same passes as before, so seismic load cases. Let's go on because we already placed everything. Now we can calculate periods, because at least we have one element upon ground level. And okay, basically this is it. Yes, next, and okay, now we don't receive no more the warning that there are no structural mass, because as I said before, we have at least one element built above ground level. Now that we have defined our load cases, that we have correctly defined seismic load cases, we can go for combinations, or otherwise we can insert manual, let's say, loads. For that purpose we use the command generic loads. Here we have a table with different kinds of generic loads. You say we have two kinds of loads for nodes, nodal load and impressed displacement. So here we can basically select a node and insert a force. Let's say punctual action. Of course we gave it a direction. Let's say we want a vertical force, so we have to insert here on FZ. something like 200 kilonewtons. Maybe it's low, it's just for the example. Okay. So, and then every time we create something inside an archive like this, we have to click apply. Let's say that I modify it, I go for 500, I do OK, and then I move on the next slot on my archive. If I come back to the previous one, it's still 200 because I didn't press apply, so no changes were saved. Of course, you have some slots. It's the same kind of archive as section and materials. Here we have kind of loads for D2 elements. This is distributed load, local distributed load. The difference is that with that you use the global coordinate system to indicate the direction of the load. Instead, while you use local distribute, you use you see F1, F2, initial and final. So you're gonna use local coordinate system of the single element. We don't want to use that right now. With the global concentrated and local concentrated, you can insert a concentrated load on a D2 element. These represent a thermal load, and to apply loads on the three elements like the ones that we have, we can use uniform pressure load or not uniform pressure load. So let's say on slot 2 that I want to have a pressure load, and here we select the value, let's say 100, and here when we ask me the reference point, it means the point in which direction the force is pointing. So basically, if you want, like this case, that force is to point low on negative z direction, we have to set a reference negative, like less 10. Okay. Now we go OK, apply. Now we have two loads in our archive, and we want to apply them to some elements. They're not automatically applied. We have to use the edit command and to click on the elements. Cases. Okay, if I select a node instead, okay, why this? Sorry, let me check. I have a force and a pressure load. So what's the problem? Okay, the problem is that probably I don't have a load case proper to insert concentrated loads. We should use a generic live load actions. So let's create one of them, apply. And then I can edit the node. Okay, so when I click edit in the load assignment context, I don't have the usual property window on the right as on the previous context, but we have this kind of window in which on the left we have the list of the available loads proper for this kind of element that I clicked, punctual actions, that to apply I have to translate it, so to grab and move inside the load case that I want for it. Okay, once that I translate it, I can open this menu, and I can see which kind of loads are applied to the elements. Of course, I have one too much, so if I want to take it off, I just grab it and move on the left, and then I go for apply. As same thing, if I want to apply the pressure load as I defined it before, I go edit on the free element. Here I have some kinds of pressure loads. This is the one that I defined before, the others are predefined loads. As before, I have to grab it and pull it on the proper load case. Apply. Now I applied 2 loads. To check if that worked, I can use this button, View Load Case. With the View Load Case, I can click it and automatically the software is showing me the loads. So on this node I have this force, and on the D3 element I have this pressure load that is represented like this. Now they are both going up on the positive direction of the zeta global axis. To correct it, I have to go on load data, generic loads, and this happened because here I used a positive value. Positive means the positive direction of zeta, so I have to place a minus. I go OK, I go apply, and then if I refresh my view, we can see that now is going under. And same for that. I go on load, generic, I move to the second slot. To modify value I have to click again on the kind of load. Here I can basically insert a minus on the value, or move the zeta reference on the opposite side. I go OK, apply, and then if I refresh, we can see that the load is correctly applied. And basically, okay, these are the kinds of load that I can use. Of course, we also have linear loads, uniform, all punctual, concentrated, but right now it doesn't matter. I mean, it doesn't need to show you. I think you understood how does it work. You can try by your own. And as last thing, we have to go for combinations. So always on load data. We can go combinations. Here in this table we were gonna create our combinations. Usually we first go for general settings, in which we can, for each load case, define which are the psi, so the coefficient for that load case, depending on the kind of combination. On the next step, variable loads interactions. In this case we only have one, so we cannot define the interaction with itself. Let's create one more to check what happens. And on the last step we have the duration of the load and its value reference. All these parameters influence the combination generation. Here we have our factors, always depending on which kind of combination are we going to create, always based on Italian normatives. We can click end. Now if we go ultimate limit state structure, the software is gonna create automatically the combination. If we want to create one by our own, we have to go with the add button. So a combination is automatically created, in which we can modify values by our own. I can insert one for load combination 1, one also for load combination 2, and go on. Each time I modify a value, to make the software save it, I have to click it on another part of my table. For example, if I select one on the load case 4 and I go OK, then I go back on combinations. This is not saved because I didn't click on anywhere else. Each kind of combination has a type of combinations. This is ultimate limit state, for example, and these are the other kinds of combination available. You can find them on the manual of the software. I'm not gonna explain them one by one. And okay, I think this is everything. Now if I select a combination, I can also delete it with a delete. And with delete all, I can delete everything. So here we have structural. With structural we have normal load combinations that does not include seismic actions. For that I have to use the seismic load state, and the software automatically create combinations using the 130 rule, in which each time we apply a seismic load on a direction, it's also applied 30% of the load on the orthogonal direction for every combination possible, basically. So we have one. Okay, let's go from the start. 1 less 1 less 0 3 less 1 0 3 1 less 0 3 1 0 3 less 1 less 0 3 on the other directions, and so on. So these are combinations. Once again, I encourage you to test them by yourself. Just make some tests, and then you can ask me questions on how they works, but it's really easier to try it by your own, and I think it's okay like this. You can also save the combinations with the right file. It's gonna write a CSV file. It's a sort of Excel file in which this table is saved. So you can let's say that I save it here, then I delete everything. If I go read file and select the file, automatically the same combinations are imported on this table. With the diagonal instead, you can create a combination with the diagonal, basically. So let's say I have 10 load cases, so I go 10, I create diagonal, and it creates me automatically combinations with on the diagonal. I used too much. I have to place 6 because I only have 6 combinations. No, okay, that doesn't change that much. Okay, well, basically this is the wrong use of the comma. This is needed when you import structural actions from another file. Let's say that in this file we don't model anything in elevation, so we only have our foundation slab, and we want to import local actions on the nodes that are calculated in another model. We can import them with the command import general loads file. No, sorry. With import general loads file, we can import general loads, of course. Import boundary reactions. Okay, now I don't have any file to show you how this works, but maybe if you send me by mail a file with this kind of actions in another video, I can show you how to use them. By the way, you should just import them. You're gonna receive a set of generic loads, that are divided in nodes, and then you recombinate them with the diagonal. At the moment I don't have any file to show you this, but maybe in a further moment we can check it. Okay, on this context, on the load assignment context, we don't have so many other things to do. Here I showed you that with the view load case we can view each load case. This is self-weight, this is the dynamic force for this load case, etc, etc. With this one instead, this one have just one arrow and is for single load case. This with 3 arrows is for load combinations. So here I can see all the forces in the single combination. Okay, so this is useful to check basically is we properly assigned the loads. Other commands are the same, so for the selection, active, etc., filter, so same commands that were also here in the input data context. The main commands in the load assignment context are inside this menu, load data. Basically, when we place, once we finish place our loads, we should go on context and do another kind of check. So before we had the check structures data, now we have to check load data. The software is gonna starting work, and if no warnings are given, we can go again on context. You can see that now the saving data to perform analysis is unlocked, because before the check load data this was on light gray as this, so unclickable, unavailable. So after check load data we can go saving data to perform analysis. Once we do that, we can see that in this status check report we have some informations about our structure, like the total value of the mass, activated mass multiplied for the gravity acceleration, and this is the resulting in terms of force, the Newton. Now we can perform analysis. So the steps to pass from load assignment to the next context is check load data, saving data, and perform analysis. With performing analysis, this happens. Okay, a couple of windows are gonna show up. When the status check report says process completed, we can close it. Of course, we can watch it, just check that everything is fine, how much excited mass we have in each direction. Of course, in this structure we have one element, so it's easy that the mass is 100% in each direction. And when process is completed, we can close that, and now two contexts are available now: view result and assign data. View result is used only to check the results of the analysis. So here we cannot set anything. Basically, we can just check which are the results of the analysis. As I said before, even there they are divided by load case, by load combination, and by dynamics. So these are the vibrations of our element. To see that, okay, I have to click it, and then here we can check which kind of results we want to see. We can go for nodal displacements, like I wanted the Z translation. Of course, these are very low values, because like this is a foundation plate, and we have no significant loads in this case. Okay, let's make this example more significant. Go back on the first context, input data. I want to select this and to split it in different parts. Now I came back in input data to go on faster. Without go check structures data, change context, check load data, etc. Once we passed the load context for the first time, we can use the perform analysis button here. The symbol is the one with the calculator with the flash. If we click it, the software automatically do all the checks. So the structure, the check structure, and then the load check, and automatically passes to the view results context. I did that just because I want you to show something more. For example, when we use this button to view the dynamic results, I can go here for deformations, deformed shape, and here we can see how the structure deforms for each seismic action. To have a proper sight of it, we can go on Z plus view, and now if we activate them again, we can see basically how the column deforms for each load case. Of course, we have a very low and thick column, so it doesn't move that much. It's just an example, by the way. It's always true for you that you should try it, you should model something and go check it by yourself, basically. Other kind of results that you can check, these are nodal forces, nodal translation or rotation, sorry. So the degrees of freedom of the single nodes. Here we have the result sections for that nodes. In this case, they are not available because we don't have any external boundary. We have no nodes fixed on the ground, so we cannot have results of this kind. We can, like with the two actions, check which are the actions on the D2 element. Let's say this, and of course we can go on from load case to load case. These are the diagram that is gonna show when you select, like in this case we are on the self-weight load case and we are checking the axial action. So of course it is 0 on the top and it develops in a triangular way when we go down to the base. What else to say? These are results for points, results for foundation, results for D2 actions. These are the foundations actions. So we can go plinth press. In this case we don't have no plinths, no beams, we have a foundation slab press. Okay. The software gave us a warning about positive pressure. It's because we have basically no big loads on our load slab, on our foundation slab. But by the way, the meaning is always the same. We have to click the load case or the combination in which we want to check the results, select the kind of results we want to see, and then you can move between load cases to check the results. Here we have results for the free. These are in terms of stress. These are in terms of actions. These are results for brick that basically are D4 elements, so elements in 3 dimensions. But we're not gonna use them. They're really advanced and we cannot even design them. It's something advanced that we're not gonna check on this tutorial. Here we have deformations, so as we've said before, we can watch the deformation shape. Okay, maybe this is quite too much. When we go for a deformation like this and it seems like too much deformed, like this case is 4.9, so almost 5 centimeters. And this image is not realistic. We can go on options, actions, options, and modify the strength scale. So if we go up with this number, the scale is gonna low down. Yes, it's something counterintuitive that if you go up the scale is lowered, but it works like this. If we go under 0, the scale of the deformation is even bigger. so we can keep 0, and the same display results works on even on other kind of action. So let's say if we go back on the axial action for this, if we go options, action options, we can go for let's check it, axial action scale. If we go down, you see that the diagram is gonna embiggen. If we go up, the diagram is gonna become smaller. So of course, if we have just one element to check, this is not very important, but maybe if we have something bigger and all the diagrams are intersecting each other, these options can help you on understanding better what the software is displaying to you. These commands, max and min, helps us to find the maximum and the minimum value switching on the combination. Let's say that I want, we stay on axial action. Now that we have an action selected, these commands are available. If I press max, it stays of course on the first combination. If I go min, it moves me on the combination in which this value is minimum. Pay attention that this command moves you between load combinations or load cases, of course, but when we are in load combinations, it moves only on load combination of the same kind. For example, now I lost the seismic combination, so I'm gonna redefine them. I'm gonna have OK, do again the analysis. I don't know why I lost these results. Now if I go again on the axial action, let's say that I move on the first one. With these arrows you move one to one, with these you go to the last, to the first. If I go max or min, it moves only on the static combinations. Once I move to a seismic combination and I go max, you see that it moves to another seismic combination, even if the maximum value of the axial action is given in the first static combination. Okay, so these are the main controls to check the results of the analysis, and these are controls to go for the max and the min value. As I already said, as for the load assignment context, also in view results we can just view results of the analysis, but we cannot modify anything. Now we can move to the last context, that is assign design data. So this is the context in which we can finally design our rebars for our concrete elements. In order to do that, we have first to define our design criteria. This is the last very important thing about how ProSap works. You can find them on design data, design criteria. Basically they are accessible from each context, maybe not view results and not load assignment, okay, from input data and from assign design data we can access to the design criteria. Now you have an archive, as we previously saw for materials or sections. So you have different slots available in which you can define things and then assign to specify elements. You already find some design criteria already predefined. In this case we can go for the second one, which is specific for foundations. And here you can see that you have a tab for each kind of element. So we have reinforced concrete walls, reinforced concrete slabs, beams, columns, and then other materials like steel beams or columns, masonry, timber, etc., etc. we're gonna focus on reinforced concrete slabs. And in this window you can basically assign criteria, properties and coefficients for the design. As first thing, you can check this to choose to have a non-dissipative design. Here you can choose the angle for the x-axis and the angle between the epsilon and x-axis. That of course it's usually 90 degrees, but you can modify it if you prefer. These are minimum and maximum tension reinforcement acceptable for the rebars. With these you can tell the software to design only one layer of rebars placed in the center of our D3 element. And here, of course, if we don't select this, you can specify what's the value for the rebar cover. And here you can specify the diameter for the bars in x and epsilon direction. You can define the diameter, so you can go up and go down, the spacing, and this is for the main rebars. And then you can specify also the diameter for the additional rebar. What's the difference? It is that when the software design it in first place, it places this diameter with this spacing in everywhere in the slabs, of course, where this criteria is assigned. And then, if some more amount of steel is required, then it uses the additional rebound diameter, but this is not used every time. So there are some situations in which the main diameter with the main spacing is okay, and so the additional rebound diameter is not even used. Later we're gonna see better how this works. And in the end, here we can select which kind of steel basically we want to use for our rebar. So for his yield strength, which kind of steel, and their coefficients. Okay, so these were the main properties of the design criteria. As every time we modify an archive, as we saw before, if you modify something you have to click apply. Otherwise, if I go down and come back here, the modifiers are not taken. So let's say I want 10 as diameter, I should go apply. Then I can close this, and of course I have to assign the criteria to the elements. So the procedure is always the same. We go edit, we click an element, and we modify the property design setting, which the second one, which is the one that we already modified a moment before. So we click this, we set properties and apply with a couple of clicks. Now we can close this. With property foundation slabs, I can select every foundation slab, and then right click assign criteria. Remember that now if I do assign reference, I'm gonna assign each properties of the set reference to everything is selected, so also thickness, but I don't want to modify thickness, so I'm gonna just do assign criteria. Now I can check by going on editing and click some random elements to check that the design setting is always the number 2. Okay, this is done, and now to proceed with the design, we have to select every element that we want to design. So of course nodes are not designed, so I can go with a box and select everything. I can also select the column to design it, but in this case it's just a support element, so we're not gonna design it. And I can go with property, foundation slabs, okay. And now to design it, I have to do right click, design, limit states. You can choose in the kind of design between limit states and allowable stresses. That maybe it's an older approach, but it's still available on the software. In each case, to choose one, in order to choose one of these, you need to have combinations of this kind of type. Now we choose limit states. So now the software is processing, you can see down there. While doing this, if you click somewhere on the screen, it will say that the file is not responding. Don't worry about that, it's absolutely normal, just don't close the software. Give him the time to end his procedure, and basically, yes, it's that. Every time that the software is calculating something that could be designed, but this works also for the check structure data, the analysis. So every time the software is working, is calculating something, if you click on the window, you're gonna see that not responding, but don't worry about that, is perfectly normal, just don't close the software. Okay, now that the design is ended, the software gives us a warning that says that software detected the free element which requires additional reinforcements. So okay, and also that requires shear reinforcement. That's fine, it's not a problem. Once we end the design, we can go check the results of the design with this. So basically here we have the results show for each kind of element. So concrete is divided between beams, columns and slabs, while steel is all in the same button. And on the left we have results for allowable tension. On the right we have results for limit states. So now we're gonna check results for limit states for slabs. Here we can select which kind of results we want to see. The first thing that we usually check is the design status. When we click on design status, all our designed elements are going to be highlighted in a color. If this color is light blue, like this, it means that the element is verified. Basically, the element passes all the checks, and it's fine like this. Otherwise, it will be highlighted in red. Instead, if an element is not designed, it will appear in yellow. So if I, for example, if I selected half the slab, and let's have an example. Okay, I want to design just half of the slab. I go right click, design limit states. Of course, this time it will be faster. Of course, I received the same okay, so basically when you redesign something, it doesn't overwrite the already existing results. But that's not a problem, okay? Just trust me, if some elements are not designed, they will appear on yellow, just to remember you that you have to design them. And this is the main approach. Why is everything light blue, even if before we received a warning in which that told us that some elements required additional rebars? That's because of the design criteria. As we seen before, in the design criteria we can define what is the additional rebound diameter. So this warning, the warning that we received at the end of the design, just remember us that the main rebars are not enough, and the software has used also the additional rebound diameter, the additional rebars, to make the slab verified. How to check this? Basically, you have two ways. First of all, you can use the check command. So inspect, click on an element, and this window is gonna open, in which you can check the design and check status. It tells me if it is verified or no for each kind of action. And then you can open the second one to check which reinforcement has been used by the program for the calculation. So now we see that in the main direction for each direction, for the lower from the bottom layer of rebars, the software used diameter 10 with spacing 20 centimeters, and then he added the D12 rebars with 100 of spacing. The spacing of the additional rebars is calculated from the software just to reach the verified status. So we cannot define this. It's just calculated by the software based on the diameter that we choose for the additional rebar. And of course, now here you have all results for all kind of checks that the software made, and this reports you the value, the combination in which this value is calculated, and yes, all the parameters that you used to obtain this value. And okay, so this is the first thing to check when you do the design. So first of all, you go see the design status, and second, you can check single elements. And then to check where the software used the reinforcement, the additional rebars, you can go on this. AS stay for area of steel on the nodes. If you go with additional area of steel map, okay, you can see for each node the area of steel in terms of square centimeters that each node requires more to be verified. In this case, we have a value in each node of our slab. What does it mean? It means that we used a diameter too low for our slab. So in this case, what to do? We should close this, come back to the design criteria, and of course choose a bigger diameter for our rebars. So we can go up on 12, or also of course we can go down with spacing, but usually the first thing is to go up with diameter. We set it from 10 to 12. Let's try like this. We go apply, remember the apply button, and then we can reselect each element, and then go with the design limit states. We are probably gonna receive the same warning, okay, but at least this time we probably will have some elements exactly. Sorry, we'll have less elements with this problem, so with the additional area of steel required. Let's go check it. So we go limit state reinforced concrete D3, area of steel nodes, additional map. Okay, so now as predicted, on the external layer at least we have reached 0, and we still have a lot of area required. Well, here it is required, of course, because we have an element that weighs a lot, that how to say, its gravity is concentrating all his self-weight on the same node. So this is kind of an error during the modellation. We should never have an element big like this reaching only one node. So to avoid this problem, we can choose another kind of modulation for this element. And for example, we can use a cylinder of the three elements to basically distribute his weight all along a line of nodes and not just a single node. Or another thing we can do is use rigid links to distribute this weight on the near nodes. So first of all, I want to select an even bigger diameter. So once again, I repeat the process: design data, design criteria. On the RC slabs, we can go up with the diameter from 12 to 14 this time. We go apply, and then with property foundation slabs, okay, we select everything, design limit states. We're gonna receive the same warnings cause of the center of the slab that presents some kind of problems for this column. So okay, but now at least if I check the additional area of steel map, okay, you see that we have a lot of elements that now are okay with their main rebar layer, and only the center that require additional rebar. Also this layer down there, now I cannot say why this happens, because this is an radial symmetric structure, but okay, don't worry. Let's see what does I intended with rigid links to connect this node to the near nodes. So we go back in input data, and to design a rigid link, to create a rigid link, we have to just use the two elements and assign them some specific properties. So now, as the first thing, I'll just design that. Okay, let's check one thing. I used okay, a column with radius 100, so a meter of radius. I don't know if the dimensions that I input are realistic or no. I'm just doing things for the purpose of showing you how to work with the software. So forgive me if I say something really wrong in terms of dimensions. So basically what we want to do is check the dimension of the elements that we want to distribute its weight, and so 100 of radius. Now we can check the dimension of one single element of our slab, of our mesh. So with the command distance we can click from node to node and receive the distance between the two nodes. It's 31. So let's say that I want to distribute the weight on the external perimeter of my column. So I have to choose 100 divided 30, 3 elements. Okay, now what we're gonna do is to create the two elements, from here to here, and we go okay. Of course, as we mentioned before, we have to cut it with the inner nodes, with nodes that belongs to this element, but we're gonna do this later. And now I can do this for each direction. So click OK, and we can do this also diagonally. So here, and here. Okay, now these the two elements that I modified, that I created, are simply beam elements with the same section and the same material. So in order to make them work as rigid links, we have to change first thing material, and in the bottom, so the last material defined in our archive is this material. Okay, this is not translated in English, but now we're gonna see it. I save it. Okay, so we go in structures, data, materials. Okay, we are already on the last slot. This is a material without weight. So this material has no specific weight, so it doesn't weight on our structure, and it doesn't create absolutely seismic mass during the analysis, and has a very high elastic modulus. So it is an element very rigid, not infinitely rigid, because infinite it's not a number, and it doesn't allow the software to make proper calculus. So it's just a very high number, and the specific weight is 0. These are the true properties that define a material as infinite rigid, and so proper to create for the creation of infinite rigid links. So we go OK. Now we want to change the section of this, because usually when you create rigid links, you assign to them very small sections, because it's not needed to have big sections, because we have the material that it's already very rigid. So usually what we do is create a section, a rectangle one. Okay, we call it a rigid link, and it can easily be defined as a 10 per 10 centimeter. Okay, we go OK, we apply. Now we already have our element selected. I can click on it and change the section to the number 2, rigid link 10 per 10. Okay, I set properties, right click, assign. I have to assign both section and material, and these elements shares every property, so I can go with assign reference. Okay, as before, I check at least one of them to verify that the command worked. So the section is right, the material is right. I can close it, and then okay, I should intersect them with the nodes. So okay, I can select them one by one, or I can either go context, check structure data. The software tells me that there's something to correct, perhaps require additional inspection. If you go no, the software proceeds with the check, and you can go further with analysis. If you say yes, the software stops the check, and you stay on the input data, and you can modify it. So I go intersect 1, 2 times. Now it seems correct. We can so once again do the checks. As I mentioned before, you can also, if once you know that the structure is okay, that our modulation is fine, we can just use this command, perform analysis, to basically skip all the checks. Well, skip is not exactly the right term, because the software do all the checks, but automatically. You don't have to click one by one for them. So we go till the end, process completed, and now if we come back on assign design data, we can select our foundation slabs. Once again, go with design limit states, and we'll see that the results, at least on the center part of the slab, are better. Okay, if we go with the area of steel nodes additional, now on the center, okay, it's still high, but not as much as before. Okay, so basically now I don't want to reach the verified status on each node. This is let's say something that's up to you, and but I showed you how to work, how to move between commands, so when something is not verified, what to check, and how to modify it to reach a better situation. Okay, So for this first video tutorial it is all. I think I give you many information to start and using prap. So now you can try it, and of course then if you have any question, or if you want me to explain something deeper, or if there's something that I forgot to mention, of course you can ask me, and I'm here to help you.